Welcome everyone to this live stream on understanding cloud computing, Kubernetes, clusters, containers, all that with no prior experience needed. So what we're going to be using is internet resources and content to understand and kind of get used to this domain if you're particularly new and starting off. And so I had this prompt written in and what we're going to do is we're going to create a roadmap and how we can, understand and master the concepts in Kubernetes and stuff. So what we can do is first of all understand what containers and Docker are. This is just like get comfortable with the basics, and this is like your week one. Again, there's going to be other resources that I'm going to be sharing along, but you got to understand containers and Docker. And what to learn is that what containers are, what Docker CLI basics are, con creating and running containers. Now, you could practice this using these type of commands, and these are some of the resources. So let's just go ahead and follow some of these links. Okay. So this is the Docker Docs website, and it just says if you're new to Docker, this section guides you through the essential resources to get started. Follow the guides to help you get started with and learn how Docker can optimize your development workflows. And then you have the foundations of Docker, install Docker, and jump into discovering what Docker is. Again, what you can do is you can get the introduction and the foundational concepts and workflows of Docker. This is some of the developer documentation. And you can also get Docker to choose the best installation path for your setup. If I go to the CMD prompt and just type in Docker hyphen hyphen version, I have to make sure that if it's in the, you know, if it's installed on my system or not. If it's not, then I'm going to have to install it. So to get Docker, I'll just click on this and it goes here for different operating systems. And then what we're going to do is Docker Desktop for Windows, a native Windows application that delivers all Docker tools to your Windows computer. And then once we have to do this, we have to install um, these are some of the requirements here: 4 GB system RAM, 64-bit processor with system level, second level address translation, and then we have enable hardware virtualization in BIOS. This is something that is pretty essential, and you can see this virtualization. I've done this step before in some of my past videos, but you need the WSL. This is Windows Subsystem for Linux. Um, and it's essentially the reason why you have to do this in Windows and not in Mac and other Linux operating system is because the kernel by default of Windows is not Linux oriented, right? Or Unix oriented. So how do I switch between Windows and Linux containers? And then if you get the WSL, you can just type in this command. This will tell you that you already have WSL installed. So it says over here the version is 2.5.9. So this is good. We have that. Update or install or update WSL via the terminal. We can install and update it if we need. Let me just see if there's any update required. If there is, it's just going to install it for me. So, okay. I don't know why that happened. But if I say WSL hyphen hyphen update, it's going to check for updates. The most recent version of Windows Subsystem for Linux is already installed. That's really good. After that, we have installed WSL via the MSI package. There's this GitHub release page, and you can just download this version of this as well. But no, I'm gonna go into the later on download and the installer using the download button at the top of the page, or for easy double download. Okay, double click Docker Desktop installer to run the installation. By default, Docker Desktop is installed on. Okay, if I just check it out, it should be over here. Let's see. No, so what I'm going to do is I'm going to say, okay, these are some of the good commands, right? We have, but one other, we can start another chat here series on ChatGPT, and what we can say is that um, I hope my audio is, you can hear everything. But what I can do is understand. What I can do is now write a small prompt and say, uh, I need to get started with. Now, again, remember we have this prompt, right? So we can just copy this prompt, but after that we can just add in that we need to first get all the software set up, right? Set up locally so that I can practice it myself on, and then you have to provide your operating system on my Windows 11 computer. Okay. Now, now again, you can just check in. I don't know. There was a command Windows R DXDIAG. If you type in that, you can check that your is a 64-bit operating system. Okay. Um, and then it's a computer 64-bit. Let's see. Okay, great. Since you're starting from scratch, then what we have to do is, first of all, install this WSL. Just install this, go to a PowerShell or as administration and run WSL install. Restart your PC if needed. After restart, open Ubuntu from the start menu. Uh, open Ubuntu. Ubuntu. Let's see. And then we get this by default. That's amazing. Um, there you go. And this is my Linux operating system, 24.04.1 LTS. Documentation. And then this is the messages. Okay, if I do ls, okay, this is just pwd, print working directory. We're in the home. But we can't ls hyphen ltr. Okay, there's nothing here. But we can just move on. Let's suppose cd and then just tab to see what we can go to. But I mean, this is your Linux operating system running on your Windows. So uh, I don't know. I think we're in the hires folder, but we can create folders here, and then we can interact. Okay. So now that we have that from the start menu and set up a username and password, I don't remember or recall it, but after that we have to install Kubernetes, kubectl. Okay. Uh, this is the main tool that you'll need to interact with Kubernetes clusters. So in Ubuntu terminal, you can just type in this command. And then you can do chmod plus x. I think this is runnable, and then sudo mv kubectl user local bin. Okay, let's see if that works out, or I hope it works. And there you go. It's installing this password. I have no idea, but let's just try one. Okay, I wasn't that. I don't know. No. Come on. If you know my password, let me know in the comments. Okay, 3 incorrect password attempts. kubectl not found, but can be installed with sudo snap install kubectl. Okay, so it didn't work out. I'm gonna have to watch some of my old videos where I set up the password. I know this is something not ideal, but we're gonna have to do something like this. So let's go here. Um, and I think it was in the live. There was one video we did earlier. I think it was here somewhere. Where we did install it. So I'm just going to see. I think it was in the Docker
All right. So
CLI.
that's essentially it.
So let's see what's happening here. I'll explain what I've been doing here in the past. So you can see over here that um, okay. So this is a video that I created with another computer. What we're gonna do is I think it's afterwards. So after this, after this, after this. Um, I think this was also some other. Um, wow. So I think maybe it's this one. Might be wrong, but let's see.
Nodes provides the computing resource, and Kubernetes
Okay,
for
what
data
we can
include
do is instead of this way, we could say, "Hey, I forgot my um, Ubuntu password." Right? Let's see. Ubuntu password Windows. Okay, then what? Reset WSL Ubuntu password in Windows 11. Step-by-step guide. Open a PowerShell or administrator. Press Windows X, click Windows Terminal, admin at PowerShell Windows. Find your Ubuntu username. Okay, what's it even saying? Let's go out. Okay, and let's go out here as well. Okay, it's saying open PowerShell as administrator, Windows plus X. Okay, and Windows X, click Windows Terminal, admin, or PowerShell. Okay, so what we're gonna do is Windows Terminal, admin. Okay, this is the admin one. I see that's WSL hyphen version. Let's see. I mean, it does get installed everywhere, so it's in the PowerShell as well. So W find your Ubuntu username. So you say WSL hyphen L hyphen V. So this one Ubuntu stopped version 2. Okay, this will show your installed distros. Ubuntu, if it's running, you'll see it listed. Okay, so this is like a nice refresher we're doing. Launch Ubuntu as root. So replace Ubuntu with your actual distro name if it's different. So my distro name is the same. Ubuntu stopped right now, and the version is that. But I'll just do hyphen root. Okay, hyphen u root, and this will launch my I think Ubuntu. I think as root system information as of July 6. Okay. Welcome to Ubuntu. It ran, and I believe so. I'm in the MNTC users GNG. This message is shown once a day. To disable it, please create the root, whatever this thing is. But the thing is, you have everything revealed. IPv4 address for Ethernet 0, and then swap usage, memory usage, users logged in, and all that cool stuff. Okay, we're in the Mint, whatever that thing was. This is a pretty famous file path, root at Harris, which is the user, colon slash mnt slash c slash user slash gng. So basically, if you look at this, we are right now inside of our system. Um, Let me see over here. I don't know why I did that, but if you look over here, okay, this is that. But if I say, oh man, ls hyphen ltr, okay, it's you could tell me like who modified stuff. Um, like I did all of this modification, but if I just want to like a clear way of seeing these things, these are just stuff on my computer. So there's the downloads folder, there's the documents folder, the desktop folder. All this stuff is right here in my hands, right? The palm of my hands. Okay, well, replace your username with the name of your Ubuntu user. I don't know that, but let's see. Uh, okay. Okay, so what I'm going to say, replace your username with the name of the Ubuntu user. So you'll be prompted to enter a new password. Well, I'll say password, PASWD, and then I don't know the username, so I'll just say Harris. Let's see. Oh, wow. So that was my username. I'll just call it very simple, so I hope I don't forget. Okay. So password updated successfully. And then we can just exit the root mode. So just exit it out like this. Oh, and I made a mistake again. Let's see, exit it out like that, and we're logged out. See? Now they're in PowerShell back. Now launch Ubuntu normally from the start menu and log in using your new password. So let's go back again in the start menu. I think it's Windows X, and then we can just type in. I don't know. This is just some options that you could have. But if you want to run Ubuntu, just type in Ubuntu, and it should open it up. So this is our username, I believe. So don't know your Ubuntu username? You could find it you can find it by listing users, and then this shows the usernames of all regular users. I think it's like slash home. I don't know. Okay, and this is the user, right? So there was only one username, and that's why we can see that. I don't know Coop Cuddles why is over there. ls hyphen ltr. No, I don't know. I created this July 6th. Wow. Can you just remove this mk rmdir? I think so. And then the name of the thing was called Coop Cuddle. So Coop Cuddle. like this. Failed to remove kubectl not a directory. What the heck is it then? Um, I want to remove this thing, right? ls cd kubectl kubectl. It's not a directory. Then what is it, man? Okay, no problem. Okay, so what we can do is we can go back now. Let me know once are back in Ubuntu, and we'll move forward with Docker or Minikube setup. Okay. So now that we're done with that, let's start again. We're just gonna install uh, the CLI, the kubectl CLI. So again, we're gonna use these commands: curl -lo, and then the HTTP colon two forward slashes dl dot k8s.io slash release. And all of this URL, it goes to the bin slash Linux slash AMD64, and then let's see what happens here. So again, it will require my password. I'll just provide that. And again, we got the client version of v1.33.2, and we got the customized version of v5.6.0. And that was really pretty fast, 81.4 MBs lightning speed. Um, Now we need Minikube local Kubernetes cluster. Minikube lets you create a local Kubernetes cluster on your machine for practice. Okay. So what we want to do is we want to install these dependencies. We're going to do sudo apt update. See what that is. And we're getting stuff updated here. Okay. So fetched this stuff 9611 KB in 3 seconds, and we got some reading done, we got some building done, we got some ready state information done. Okay, and 181 packages can be upgraded. Okay, so now that we have done that, let's go ahead and install this thing, this Minikube, for practice sake cluster, the cluster practice thing. So let's go over here and just run this. And I didn't copy it properly. So what I'm going to do is I'm going to go ahead and put this on the left side of the screen, and I'm going to put this on the right side. And what are you going to do is you're going to have this thing. Um, so it's called sudo apt install -y, and then we have curl, and then we have wget, and we got apt transport, and then we got -https virtualbox. I hope I typed everything correctly. And when I pressed enter, it's downloading all this stuff. Um, so let's see. After if VirtualBox doesn't work for you, you can use Docker. Let me know. So, oh, okay, we're getting something else instead of Docker. Okay, so it's in the progress. You can see it's loading. It's downloading. Um, so yeah, we're gonna continue from there. Let's see what's happening here. Okay, just keep going. And then we have to install this Minikube. First, we gotta get the VirtualBox, and then we gotta get the Minikube. So yeah, it's installing all this stuff. Oh, it failed. Failed to start VirtualBox service. Okay, let's copy this and say tried. What was it? And then uh, okay, okay. Um, let's see. This is expected when trying to install VirtualBox inside WSL2, and it won't work because WSL2 doesn't support VirtualBox or any virtualization tool that needs direct access to the kernel. Use Docker instead of VirtualBox for Minikube. Minikube works great with Docker on WSL2, and it's and it's the recommended driver. Actually, why are you recommending me VirtualBox for no reason? Okay, so what we're gonna do is install this Docker, run the following commands in your Ubuntu WSL terminal. So I'm just gonna copy these. So I'm gonna say sudo apt update, and then we have okay, then we have sudo. Um, okay, let's see, sudo apt install. Okay, hyphen y docker.io. Okay, okay, it's installing all of that. Okay, now it's installed. We'll do this other thing, system cdl enable docker, and then the last one is system cdl sudo system cdl start docker. Okay, and it didn't do pretty much, but if systemcdl gives an error, AWS might not support systemd by default. We'll fix it if needed. Add your user to the Docker group. So this lets you run Docker without sudo. So user mod hyphen ag docker user. Let's see what this is. Um, okay, then sudo user mod. Okay, hyphen a g docker, and then we have dollar user. Okay. Then what we're going to do, then restart WSL, close the Ubuntu terminal, run WSL hyphen shutdown in PowerShell, open Ubuntu again. Let's see what happens here. Uh, okay, so let's see. This is the terminal. Then go to PowerShell, I guess. Just go to here. And then I say WSL. I think it's just gonna give it's just gonna give what's it called? A restart, a shutdown and a restart. Okay, so it worked like that. I'm gonna have to clear that out. And I'm gonna go to the um, Ubuntu thing. So over here. Now we're just gonna go ahead and test Docker. The way to test it out is, yeah, there's a lot of system configuration, but to test it out and see if it actually works, you can just type in Docker run, and then we have hello hyphen world. I don't even know why, but let's see what happens. Unable to find hello world. Oh, unable to find image hello world latest locally. And then latest pulling from library hello world. Pull complete. So it did pull something. They gave us SHA-256. I don't know if it, yeah, it is a SHA-256. Some kind of character sequence. Downloaded new image for hello world latest. Hello from Docker. This image shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The Docker client contacted the Docker daemon. The Docker daemon pulled the hello world image from the Docker hub, AMD64. The Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. The Docker daemon started that output to the Docker client, which sent it to your terminal. Stream that output to the Docker client, okay? To try something more ambitious, you can run an Ubuntu container with. So we have Docker run -it, and then we have Ubuntu bash. Share images, automate workflows, and more with a free Docker ID, okay? And then for more examples and ideas, visit this website, docs.docker.com/get started. If you go here, you just see all this information here. But it's pretty cool. I like it. And it has just the foundational and fundamental features you want to learn. And it was just going to give you more and more resources. But yeah, you should see a success message. We did see that. Install Minikube if not done already. So let's see if this one works now too. Just copy this and just curl -lo https colon two forward slashes storage.googleapis.com /minikube /release /latest /minikube hyphen late Linux AMD 64, and then we have the sudo install minikube hyphen Linux AMD 64. And what we're going to do is we're going to press the enter button. It should install that for us with our password in. So yeah, I mistyped our password, but once I provide it, it should install it for me. I don't know if it installed, but it gives me 126M and I provided the password, so it should be done. But if not, you can just always do this again because it should work. Like, so let's see. That, okay. Okay, it's installed. Okay. Okay. Download. Yeah. So now that we have done that, start Minikube with Docker driver. Minikube with Docker driver. Okay. Let's see what this command does. So let's copy this and paste it right here. No. Um, Minikube, and then we have start, have driver, and then we have equal to Docker, like that. I think so. That should Minikube Minikube v36 on Ubuntu using the Docker driver based on the user configuration on Docker driver and root privileges. All of this stuff is happening, and once it's done, I believe so, we will be able to start Minikube with Docker driver. Summary of what you're doing. So we got the Docker required to run Minikube in WSL2. Then we got Minikube, creates a local Kubernetes cluster. And then we got kubectl, interacts with the containers, Kubernetes clusters. So let me know if you run into any issues during the setup processes, especially the Docker inside WSL2. Some setups need enabling systemd, which I can guide through if necessary, but creating a Docker container. Uh, and it has two CPUs, memory is this much, but it's creating our container, whatever it is. Um, and let's see what happens. Okay. After that, we can go on to the next part and run some of the commands within the cluster, that practice cluster, right? So I guess it's creating Docker container and then preparing Kubernetes v1.33.1 on Docker 28.1.1, generating certificates and keys, booting up control plane, configuring RBAC rules. I remember those things. Configuring bridge CNI, container network interface, verifying Kubernetes components using image GCR.io, enabled add-ons, and done. kubectl is now configured to use Minikube cluster and default namespace by default. Okay, we have a default namespace. Okay, I think so. If I say kubectl hyphen version, it should give us the no, or maybe it's just like this. There you go. So client version v1.33.2, customized version v5.6.0, and server version v1.33.1. And if I do kubectl hyphen get and namespace, I think so, like that. Okay, so you can see over here we have the default one, and it's active, and it's just 72 seconds. Kube node release, kube public, and kube system. All of these are there. So this is how we get the namespaces. Okay. If I do ls, I'm in Minikube Linux AMD. Okay. So yeah. So what we're gonna do is we're gonna go ahead and see if Docker is there as well too. Let's see. No. Okay, there is Docker too. Okay. Okay, I think so. We're in this. See Docker run nginx. Okay. nginx. Unable to find image locally, so it's extracting it from the Docker hub, and after some time, it should be added within our particular working namespace, I believe so. Um, well, let's see what happens. So it's taking a little longer than usual, but um, now I can. A minute, so what do I say? Okay, let's see if we can do this. Okay, so this is the week one thing, and I believe so. This is like a complete journey. So okay, so am I now inside? Uh, I don't know. Let's say uh, what's it called? A cluster within. Uh, let's say default cluster within the Docker what Docker image using kubectl. Also, can I now run the following? See what happens here. So perfect, you're on track. Let's clarify where you are and answer your questions. Are you now inside a default? Are you now inside a default Kubernetes cluster using kubectl? Yes. If this get nodes, you should see something like this. Okay. There's just one node, and it's in the ready state and as a control plane. And as this confirms your kubectl is connected to the Minikube cluster, running on Docker, and you're inside a local Kubernetes environment ready to use. Okay, let's see. I don't know why. It's like kind of like I had to do Control C to exit all this stuff out. But what was this command actually? It was a command to run nginx. But if I just do kubectl get nodes, let's see. Okay, we got the Minikube ready control plane, and exactly the same. It's there. It's ready there. Can you start? Can you now start phase one? Absolutely. Let's go by phase. Let's start. Let's. Here's how to go through each part. Now, what to learn? What are containers? These. Think of them as isolated, lightweight mini computers that run just one app. Okay. And then we have the CLI basics: Docker run, Docker PS, Docker exec, and Docker build. Practice in WSL. Let's try these commands. So first of all, let's run an Nginx container. To run that, you do docker run -d and then -name and then my Nginx nginx nginx. Okay, ng nginx. Why is it so weird? Nginx. What the heck is that? Let's say what is nginx, right? What is nginx and why is it named like that? Let's see. So, um, Nginx. Okay, Nginx. Sorry, I didn't even know how to pronounce that. Is an open source web server software that is widely used to serve static web pages like HTML, images, CSS, JS, act as a reverse proxy to forward client requests to backend servers, function as a load balancer to distribute traffic across multiple servers, and handle API traffic or serve dynamic content with help from backend frameworks or via fast CGI or PHP. Why is it called? The name Nginx comes from Nginx. The idea was to make a high performance engine for serving web traffic. The original developer, Iger, created Nginx in the early 2000s to address the C10K problem, handling 10,000 plus simultaneous connections efficiently. He chose Nginx to reflect this fast, efficient engine. Over time, it became stylized as Nginx, a Unix style name. Why is Nginx popular? Because it's fast and lightweight. great at handling high concurrency, perfect for reverse proxying and load balancing, often used in front of apps built with Node.js, Python, PHP, Go. Often used in front of apps. Okay. What is Nginx? It's a fast, efficient web server and proxy tool that powers much of the modern web, like Netflix, Airbnb, and GitHub. That is insane. Okay, anyways, but we got this, I think Nginx, no? We're gonna have this Docker run -d. So it's running an Nginx container. It gave me some kind of hash. Okay. C running containers. So if I do Docker PS, I don't know what it's giving me, but it gives me container ID along with, okay, I gotta like zoom out a little. Okay, so it's a little small, but it's a little better for me. So it's a container ID, and this is the ID. The image is Nginx, and there's another one, which is gcr.io minikube. Okay, the command is this thing, and it was created like 6 seconds ago. The other one, the minikube thing, was created 8 minutes ago, and status is up 9 seconds. Ports, it's in the 80/TCP, and the other one, minikube thing, is on the other one. So these are just two containers, right? Run naming containers. What now? PS. What? Let's see. What does PS mean? Let's see. Okay, let's see. I gotta have to always click, man. Uh, Process status, just like in the traditional Linux command PS. Okay, it shows you a list of running containers, similar to how PS shows running processes on a Linux system. Process status. Okay, and then it just gave us this thing. You'll see output like this. Okay. Okay. So after that, enter the running container. So shell inside. Okay, we got a shell inside that. To shell inside the running container, which is this, do I have two, right? We have two containers. So we want to shell inside the Nginx container. To go in there, we go docker exec -it my nginx. Okay. And then we're gonna just say bash. We want the version, I mean the mode to be on bash. So we're inside this particular container, running container. We just shell we just shelled inside it. And stop and remove the container and docker stop nginx and docker remove to remove it. Create a simple Docker file. Save this as a file called this thing. So build your custom image. Okay. Run your image. Now visit this thing in your browser. You should see hello CKAD. Let's see this whole thing in process, in exec, in process. Um, Now stop and remove the container. Like we're in the thing, right? So we're in this thing. I did ls, and I have some random stuff here: bin, root, boot, dev. Um, so what I want to do is um, I want to stop this Nginx running container. So I say docker stop my nginx, and then ooh, we're in the container, so it's not able to stop it until we exit it out, right? So I think so. If I exit it out, then I say docker ps, and then I say docker stop my nginx. Oh, so like this, it's gonna stop this thing. It just spit out the name, but when I say ps process status, I think, and then you can see now I don't see that anymore, right? Because I think it shows the running ones. And then if I say Docker, um, remove my nginx, this is going to completely remove the thing from my system. So if I now say Docker process status, it's still going to show the Minikube one. This is just process status for the ones that are currently running. But now for all of them, they don't exist, right? And I don't know why when I like, but our 20, but there are 20 similar ones. Okay. Okay. Now that we're here, create a simple Docker file. Save this as a file named Docker file. Okay. From Nginx, run echo, hello CKAD. Okay. So we removed it, but now why are you saying, okay, I have a feeling from nginx hyphen run echo, okay, user share nginx HTML. See, I think it's just gonna create a file for us, ls. Okay, there's the, ooh, I misspelled the name, man. So I could just say rmdir, let me say docker file, fill, not a directory. I don't know what the heck are they. So I forgot the E over here. Now if I do it, it's going to be 2, right? So after that, it's just some kind of HTML I'm seeing here. But there's some index.html file as well. Build your custom image, docker build hyphen, okay, I think it was a name. So hyphen t my app. Let's see, docker build hyphen t my app. Dot, the legacy builder is deprecated and will be removed in a future release. So it's a install the okay, build hyphen t my app. So deprecated, the legacy builder is deprecated and will be removed in a future release. Install the builder X component to build images with build kit. So this is another alternative thing, build kit. Okay, but what you can see is that we have sending build content to a Docker daemon. It was 1.024 GB, insane. And then step one was from Nginx, this thing. Step two was run echo this thing, hello CKAD. And then you can see over here, users share Nginx index.html, running, removed intermediate container thing, and then successfully built, successfully tagged my app latest. Okay, so now that we have built our custom image, we want to run our image. So we want to run this image on a local platform 8080 port in your browser. So let's see what that works like. So you can see over here, we now visit this 8080 in your browser and you should see this thing. So let's see, go over here and then run it here. And then you can see over here, it's running locally. Interesting, interesting. Pretty impressive. Okay, how much are we there? Okay, 45. I don't know how many concurrent viewers are there, but if there's any like messages, throw them in the chat. Love to answer your questions. But other than that, let's go and further learn Kubernetes core concepts. Let's try what you wrote now, but that your cluster is running. Let's try what you wrote now that your cluster is running. Okay, practice commands. Run these in Ubuntu terminal. So create a deployment, expose it via a node port service, see all the running objects to access the service. If you get stuck, okay, resources and all that stuff. But so far it's like pretty impressive. If I go here and now move on to the next part where we're just gonna learn some Kubernetes concepts. Um, so we're gonna run these in Ubuntu terminal. So we're gonna kubectl create deployment. Then we have nginx, and then we have hyphen image equal to nginx. Okay, let's try what you wrote now that your cluster is running. Okay, before all of this, I just wanted like to recap what we did over here. Um, can you recap uh, what you did here before moving on? Moving on to the onto the Kubernetes part. Okay, let's see. I just hope we get a quick summary, right? So yeah, and I was at a Docker practice. What we learned how containers work using Docker commands by running and building a containerized app, run a pre-built container. So we had a run hyphen d and then hyphen hyphen name. We had a pre-built container first. It ran the Nginx web server in a container named my-nginx. Okay. The hyphen d means detached, runs in background. Okay. So now new information, pretty interesting to see. Uh, then we have view running containers. If you do like process status, Docker process status shows info like container ID, the image, the status, the ports, and the names. Confirms your container is running. Only shows the ones that are running actually. And then after the enter the command container shell. To enter the container shell, like suppose you get like the pre-built container built for Nginx, right? Web server. You want to go inside of that shell. You want to shell into it. You will go to docker exec hyphen it, and then you give the name of the container, which is my Nginx. Then you do a bash mode. So say opens a terminal inside the running container and lets you explore the container's file system or debug if you want to. Then we basically stop and remove the container. So we exited out, remember? We did a docker stop nginx. So that just stopped the running process or status of it. But if we wanted to completely remove the container, we had to use the rm command. And then you just said docker rm my nginx, name of the container, running container. And that completely removed it from our system. And it gracefully stops the container and removes it from the Docker. Okay. And then we created a custom Docker image, which allowed us to create a custom Docker file with a basic HTML page, right? Create a custom Docker image. And what it did was it had some of this content inside, run EQ, and then you had this. So this, HTML header tags was being displayed here, right? So you can see over here that this is the path of where the file existed, and it was going to be inside of a Docker file. Okay, it was a custom Docker file that we created, and we used the official Nginx images as the base. Okay, adds a custom web page to display hello CKAD, and then what we did was build the Docker image. Once we created it, created the custom Docker image, we build the Docker image. We created the custom Docker image, and then we build the Docker image by using docker build -t and then my app dot. And I believe so that it was in the current directory. Docker builds your Docker image and tags it as my app. So that was the tag to it. And the dot refers to the current directory where your Docker file is. That's exactly what we were talking about inside of it. We make sure we have the name as this, right? So that it all works out. You don't want to misspell it, okay? And then like we had a misspell here, and you see that, but then I corrected it and I had this one. I don't know if you could go inside of it because it's not like a certain file or something. Docker. It's not that, but if I do cat, let's see, Docker file, it just gives me the content inside of it. So, from Nginx, and then remember, it had the escape sequence here, \n, and then it had the run echo, you see that? And then it had these single quotes because again, you have double quotes outside, so putting single quotes in here would allow us to have this as rendered HTML content. And then this is going to be inside of this index.html. The path was set, and that's why this is the content that was included. Okay, so when we build the Docker image, like Docker build -t my app, it builds the Docker image and tags it as my app. Again, the dot refers to the current directory where our Docker file was, and then we ran our custom image using docker run -d, again, detached -p, which is running in background processes, and then we had 8080:80 my app. So it runs your custom image. This -p 8080 port 80 maps port 80 inside the container. Okay, inside the container maps it out to port 8080 on your machine. Results were that you open your browser and go to this URL, and localhost port 8080, it was mapping it with the port 80 of the Docker image. And what happened was that it will see our result like that. Hello, CKAD. This covers the core container lifecycle. It kind of covers the core container lifecycle where, let's see if I can have a paint here. So the cycle says like this. So we have create, run, inspect, build, and remove. So create, okay, and then we have run, and then we have inspect, and then we have remove. And then we can just go back to create. So these are like the 4 steps. So create, inspect, build, and remove. I forgot the last one, man. Uh, so 1 minute. Let me go here and so create. Oh man, I would need like a better format font. See, where's the text size? Calibri, bold. See, okay. So first of all, create. Okay, and then I think it's called create the image, right? The core container lifecycle. Core container lifecycle. You know what? I'm gonna actually make the text bigger because I don't like this one. Let's see. Cha-cha-cha. Or maybe just create a new one. Okay, don't save that one. And make the text bigger. Bold. This one looks good. Make it red so it's prominent. Uh, okay. Say core container lifecycle. Okay. So so this container lifecycle starts with what? We create an image, right? Either it's a custom image or whatever, like how we did with the one. Then once we're done with the image, we run the image, right? After running the image, we go to the next step. We inspect the image. When it's running, we want to inspect if it's working all good. We inspect the image and then we build the image. I think that, so build. Okay, oof. Oh man. Okay, I just randomly pressed some ink thing, but I had to select the selection. Okay, that's nothing, and that's just ruining everything. It was some kind of text like this, I think. So create, build, ins okay, no, create, run, inspect, build, and then I think remove. I think it's like that. Let's see. Create, run, inspect, build, and then remove. Let me know if you're ready to continue with Kubernetes core concepts or if you want a small quiz or task to reinforce. Let's have a small quiz, okay? Before we move forward. Okay. So let's see what happens here. So this is just gonna help you guys out. Here's a short Docker basics quiz to help reinforce what you just learned. No pressure, just to solidify the concepts before we dive into the Kubernetes. So Docker mini quiz. What does the following command do? So Docker run -d detach mode -p, and then okay, runs the Nginx image. Let's see what it does. I'm seeing that it's running the Nginx image interactively. Maps the port 8080 in the container. No, in the it maps the port 80 of the container to the port 8080 of your machine and builds a custom. Well, it kind of like maps it out, I believe so. So this one, C. What command would you use to see a list of a list of Docker running Docker containers? Again, simple. Um, you're gonna use Docker PS process status. C again, and then we have which of the following lets you enter the shell of a running container named my app. That's easy again. Um, you have to have bash at the end, right? Just a bash mode, but docker exec hyphen it my app. This one again C. Why is it all C? What does this Docker file do? So this is this from Nginx run, yeah, echo again. It kind of it okay. I don't see here. Um, okay, so this is just the content of the Docker file, right? It what it does. Build a new Nginx server with a custom homepage. Deletes the default Nginx HTML file. Creates a database container. No. Installs Node.js. No, no. It builds a new Nginx server from Nginx run echo. User share Nginx. Okay. With a custom homepage. I think that's the A option. What happens if you run this command? Um, Docker stop my Nginx and Docker rm my Nginx. So start it stops and permanently deletes a container. That's the C option. And I'll let you know what you did. Okay, so one C, two C, um, yeah, okay, three C, uh, four A, um, and this one was five C. Let's see how we do. You're absolutely ready to move forward. Here's your results. Yay! Okay, you're solid on container basics. Let's move level up and move into Kubernetes core concept with confidence. Would you like a similar quiz-based plus hands-on learning structure as we go through pods, deployments, and service? Absolutely. So let's start. Uh, let's go ahead. Let's start out. All right. So let's see what happens here. Um, the most important foundation for it. Okay. So understand and practice these key concepts or components. What are these key components? This pod, deployment, service, namespace, config, and whatever this thing is. Let's go here, throw it in the chat so that you guys also have this information. I know it's no space, but you're gonna have to manage it out. Um, Pod, deployment, service, namespace, config, map, and secret. Okay. Pod, deployment, service, namespace, config map, and secret. We'll go one concept at a time, learn it, practice, quick quiz. Let's begin with the most basic building block, pods. What is a pod? It's the smallest unit in Kubernetes. It wraps one or more containers with shared storage, network, and a spec for how to run them. One pod equal one container usually, but you don't manage containers directly in Kubernetes. You manage pods. That's one thing you got to understand. A lot of beginners make a mistake on is that you don't manage, you know, so K8s, you don't manage containers. Don't manage containers directly. What we do is uh, you manage the pods. So let's try out commands to try run this in your Ubuntu terminal. So let's see how this goes up. Let's go back to our Ubuntu terminal, fire it up. Uh, Create a single pod running Nginx. Okay. Kubectl run my pod hyphen hyphen image equal to nginx. Okay. Hyphen hyphen restart and then equal to never. So what's happening is that we're creating a single pod running nginx. Kubectl run pod, run my pod was the name, hyphen hyphen image is equal to, oh no, run my pod and then a hyphen hyphen image equal to nginx. So it's a pod running nginx and it's created. Okay, check the pods. kubectl get pods. And you can see over here we have my pod, container creating, restarts and in 15 seconds. Get more details, you could say kubectl, describe pod, and then the name of the pod, which is my pod. This is going to give us more details about it. Okay. Kubectl describe. I didn't spell the describe properly. Yes. And I just messed up here. Um, so again, what we do is uh, kubectl get pods. It gives us my pod, which is running the Nginx image, and we want to enter, or before entering the container inside the pod, right? Okay, so there's a pod, and inside that pod, so pod, there's a container. Okay, got it. So think of it like this. What we have here is, let's create a new one. Yeah, whatever. Let's save it as container lifecycle. If you need these things, I might share them on Discord or my Patreon. Okay. Anyways, what we can do is let's try it out. So, uh, bad. Let's have a thickness brush. So what we have here is we got this container inside. Let's make it a little shorter. Okay. So we have a container inside here. Think of it as a box. Remember what a box is? A lightweight computer, something, whatever. And we have a pod outside. No, no, not outside. Technically, this thing is a pod. This black, this dark one. So we want to like run or go inside this, and that's exactly what we're trying to do. Let's go back here and continue. So to get more details about that running pod, we say kubectl describe DSCRIBE pod, and then we have my pod, and it will just describe it in its English language that it's a name as my pod. It's a namespace is called default. Priority is 0. Service amount is default. The node is this thing, which is minikube, and then slash 192. Start time was this thing. The labels are my pod, and there's the IP for it, and then there's other information that you could get. Okay, so enter the container inside the pod. So to enter in the container, what we're talking about inside the pod, what we do is kubectl exec hyphen it my pod and then hyphen hyphen bash. Now, what happened is that we went inside the pod and we put in the mode bash. So we're enter the container inside the pod. Wow. Okay, that's insane. So you can go ahead and see the architecture. I think it was similar to the last time. Remember when we were doing it directly through Docker? But this time we're doing through Kubernetes and seeing that the architecture is kind of similar. The folder structure, um, and the content and the debugging we can do. But again, we can just exit it out. Okay. Deleting the pod, kubectl, get pods. And then with this, what we could do is just delete it using kubectl delete pod, and then we have my pod. Should delete it. Okay, cool. Now we say kubectl get pods. It should have no resources found in default namespace. Kubectl kubectl get namespace ns. You can also do that, and you can see the same stuff. Okay, let me know if any of these don't work, and I'll fix it for your setup. Now YAML, you'll need this for CKAD. So here's the equivalent YAML definition of the pod above. So what is this YAML definition? Save the pod, save as pod.yaml. API version v1, kind is a pod, metadata is a name my pod, spec the containers. And in the spec, we have a container that is a nginx image and all that. So it's an image. When you run it, it's a container. When it's inside of a pod, all the things like come together, and you can apply it after running. Here's the equivalent. Okay, if I like suppose vi pod, I don't know if that is actually gonna work, and apply meaning would it would actually right into it. But let's see. It's just an experiment. So if I say vi uh, pod dot yaml, it opens up the vi editor. I think it was like colon I or something. Insert. No, I. Okay, we should be in insert mode. I did I. When I do I'm in insert mode. So if I just like copy this and let's see if paste it here. Okay, this is just a comment on the top. This is the API version. It's a YAML file. Remember, kind is pod, metadata, name pod, and then spec name is all of this. If I do colon, sorry, if I do escape, okay, I did it messed up again. I'll do insert mode and I'll delete this thing. And then I'll do escape colon WQ and then exclamation mark. It should save it. ls. I see that. If I do cat pod.yaml, it should like show me the contents and only, right? If I want to apply it, meaning I just want to like create it, it's just going to create a pod for me with the container running the Nginx image. That's all it's going to do through this YAML configuration that I've created using pod.yaml. If I do the kubectl apply command -f, I'm not sure what -f means, but if I do pod.yaml, it created the pod. If I do that, or sorry, if I do kubectl and I say get pod, and then I have the running pod. And again, we have the same thing again. So we got the running and get more details about that pod. It's called my pod again because it was a name. It was set over here. Remember? Yeah. So after that, what you could do is just get more information again. You could do the same thing. Kubectl describe pod and then my pod. And then you can just see information more about the same thing. It's kind of similar. Pulling image Nginx, successfully pulled image Nginx. Again, all of that is being done automatically. It's super fast and super efficient. And to enter the container inside the pod, you can just go ahead and simply do kubectl and execute the pod called my pod and go through the bash environment. And again, you're in this particular directory, exiting it out, and kubectl deleting the pod would basically delete it again. Where if we say kubectl get pods, no longer there. No resource found in default namespace. Pretty nice practice for that. So this is just a mini quiz before we end up or conclude for this session. We might have another one, particularly on the demand. But what does a pod usually contain? Um, Now it contains one or more containers, right? That's the C option. Uh, which command creates a pod named test pod using the Nginx image? Okay, so you can yeah. So this thing kubectl run. So you can just create a pod using kubectl run test pod, right? And then image in the image side, you would just have the Nginx image, and then the restart section, you would say never, and this should create a test pod for us, where if we see kubectl get pods, you'll see now. Oh, I didn't spell it properly. Kubectl get pods. Okay, and I could see that the test pod is running, and then I say kubectl describe crib test pod. I think I don't know. Uh, the server doesn't have a resource type test pod. I think you got to put in some other parameter inside. Uh, so okay, you can run that too as well. It's something over here is some describe command. Okay, okay, okay. It you have a resource, so it's gonna be called a resource, you know. So you could call it describe pod, and then we have the test pod, and then it gives you, okay, it pulled up this information. This was the container ID for that particular test pod, and yeah, image has this one, Docker pullable. All of that looks good. And then again, if you want to go into the thing, or yeah, exec-it. So again, this one was the command. To run, command creates a pod, run test pod, named test pod, and using the Nginx image again over here, which is C. So 2 is C, 1 is C. What does the hyphen hyphen restart equal never flag do in kubectl run? Okay, this is some question that I wanted to know. Disables the pod. No, prevents the pod from ever starting. Nah, runs it as a one-time pod, not a deployment. Restarts the pod continuously. Uh, I think it says maybe it's this. How do you enter a shell inside a running pod named mypod? So to enter a shell, remember we were about to do that. We use the exec command. So we say kubectl exec -it mypod and then hyphen bash. That's B, 4B. Okay, so reply with your answers and let me know if you ran into any issues applying or exploring pods. And we'll move on to deployments next. It's getting more and more interesting. Okay, so 1 is C, 2 is C, 3 is 3 is uh 3 is C too. Okay, one time pod, yeah. How do you enter a shell inside of a Okay, that 4 one was something else. It's it's B. Okay. Anyways, just get some information here. Understanding I haven't restart never in is keyword. Okay, what is this? What does restart do? Kubectl run my pod. Okay, run my pod. Okay, telling you. I want to run a single pod. Okay, not a deployment or a job. And if this pod stops or fails, do not restart it automatically. That's exactly what you're telling Kubernetes to do. Why this is important? By default, kubectl run creates a deployment. Okay, by default it does, which manages a replica set and keeps pods running continuously. And you don't want that. But when you add the hyphen hyphen restart equal never, Kubernetes instead creates a bare pod, not controlled by a deployment, job, or anything else. Use cases, one-time pods for debugging or testing something quick, like running a shell or like a one-off task. Um, like just say kubectl run test pod. So one-time pods for debugging or testing something, like running a shell or a one-off task. So I say kubectl run test pod. Now, now this the thing here is like, okay, one time pause for debugging or test. Okay. Um, yeah. So, okay. Okay, busy box is the image. Okay, command. Okay, hyphen command, hyphen sleep. If you want to manually control the pod lifecycle, running like running a shell or a one-off task. Okay, I understand. So hyphen restart is always creates a deep deployment. Okay, and hyphen restart equal on failure creates a job, and hyphen restart equal never creates a pod. Okay, let me know if you want to practice writing each of these. Okay, I got the gist of it. And let's see what it works. Boom, another perfect score. You're crushing it. Seriously, let's go over your answers real quick. Pods are wrappers for one or more containers. Okay, good. Correct syntax to create a standalone pod using kubectl run. Okay, okay. And then ensures it's treated as a pod, not a deployment. Again, kubectl exec hyphen it my pod hyphen bash is how you get it. A shell in the pod. How you get a shell in the pod? Okay, now it's deployment. What is a deployment? A deployment in Kubernetes manages pods at scale. All right. So again, remember when we were doing that, we were just testing out the bare bones, the minimums. Okay. And what we do is like hyphen restart, and then we have equal to never, and this is basically ensures it treats it as a pod and not a. Okay, it's just a pod, a standalone pod. I don't know what you call that, but it's just like something where one-time pod for debugging or testing something quick. That's why you want to do something like that. But when you want to do it a deployment, so in Kubernetes manages pods at scale, this is something different. Like, okay, um, okay, okay. So we say deployment, it manages the pods at scale. I'm trying to finish on 4 p.m. So ensures the right. So you can see the time over here, 3:51. The right number of pod replicas are running. Deployment in Kubernetes manages pod at scale, ensures the right number of pods are running. Old versions are replaced with new versions, and failed pods are automatically restarted. Now, let's get this, figured out. The right number of pod replicas are running. What is that? Okay. Um, Old versions are replaced with new ones. Rolling updates, again, it's continuously running, so it would always have the latest versions. Failed pods are automatically restarted. Again, I don't know what pod replicas are. All right, so let's go here. Uh, are they backups? The original pod? Let's see, what is this? In Kubernetes, replicas are identical copies of a pod and that run simultaneously. Okay. Okay. Not backups, but active running copies. Oh. So what are replicas? Replicas are basically identical copies of identical copies of a pod. Interesting. That run simultaneously, not backups, but active running copies. Think of it as like if one pod runs your app and you set replicas three, Kubernetes will run three identical pods at the same time, all doing the same job, like serving web traffic or something. It's good for load balancing. Um, are replicas the same as? No, replicas are not backups. But here's the difference. Replica is a live running copy of your pod. A backup is a stored snapshot of data config to restore later. Why use replicas? High availability. If one pod dies, another is still running, right? Another others are still running. Load balancing, again, what I was talking about. Traffic can be spread across multiple pods so that you don't have like 100 people in one particular pod. You could have them balanced to 50-50, or you have three. You could do, I don't know, 33, 33, 33, and one is left. So you could do eeny, meeny, miny for that last one. But scalability, you can serve more users by adding more replicas. Okay. And an example is this thing. So kind deployment. Again, they're all YAML configurations. API version is apps v1, deployment, metadata, my nginx. Replicas are three. Um, okay. Spec, again, you put in the spec thing, okay? And the name thing is my nginx, okay? Then we have okay, app is this. App is the, again, template, metadata. Um, and again, we have containers, okay? Okay. A template, metadata, app, labels. Okay, I have a feeling that is that we have a pod, and it would contain the Nginx image as a running container, but it would have three different copies. Okay, keep three copies of the Nginx pod running at all times. If one crashes, the deployment automatically replaces it. That's the power of Kubernetes managing replicas. Okay, okay. The right number of pod replicas are running. So a deployment in Kubernetes manages pods at scale. Old versions are replaced with new ones, and then failed pods are automatically restarted. In the real world, you barely use plain pods. You almost always use deployments. Um, okay, try it out. Let's create a deployment, and then let's see how it wraps up. But before that, I just need to pause for a short moment. So I'm gonna um, pause for a second. Let's see if I can show something. Is this visible? If this is visible, that's nice. I'm coming back after a short moment. Uh, So let's go and continue on this last part. And I assume that we're gonna complete it and wrap it up. So again, we're gonna create a deployment. A deployment in Kubernetes manages a pods at scale, right? It ensures like the right number of pod replicas are running, old versions are replaced with new ones, rolling updates, and failed pods are automatically restarted. Um, so to create a deployment, what we can do is create. Okay, we have this command. Let's go ahead and put it on our terminal. Go ahead here. Okay. So what we're going to do is create a deployment with say kubectl, create deployment, and then we have web app, and then we have the image, and it is like a pod, honestly. If I like just to confirm it, but but continuously running. Yeah, let's see. Let's see. Next question. Okay, no, a deployment is not the same as a pod. A deployment is a higher level controller that manages pods. It doesn't run the pods itself, but it tells Kubernetes how many pods to run, what images to use, and keeps them running as desired. Think of it like this. So, a unit that a pod is basically a unit that runs one or more clusters, right? Or containers, sorry. Right. Now, a deployment is a manager or controller. Okay, it's kind of like a manager, like a super manager that creates and maintains the pods, usually with multiple replicas. Okay, not exactly. Here's the key idea. A pod by itself is fragile. So our question like, is a deployment the same as a pod but continues to run? No, a pod itself is fragile, but it crashes. If it crashes, it doesn't come back, right? That's why a pod is super fragile by itself. But a deployment ensures the desired number of pods are always running. So like it's a manager like ensures that everything is running, everything is working together, right? If a pod dies, it automatically restarts a new one. And if if you scale up to 5 replicas, it will launch 5 pods and keep them alive. So so it's not that the deployment itself is restarting, it's recreating pods as needed to maintain your desired state. So it's not restarting, it's technically recreating new ones when something dies. An analogy would be like analogy would be in the real world where imagine a coffee shop manager like a deployment who always keeps 3 baristas pods on shift. Okay. Now, if one barista leaves, the pod crashed, the manager hires a new one immediately to maintain service, making sure that the whole process is very efficient. Let me know if you want to use the YAML difference between, if you want to see the YAML difference between a pod and a deployment, we could see that. Show me. But let's go ahead and try to like wrap up this thing. So, grading a deployment is just a manager. Um, create deployment web app, have an image, and then we have Nginx. So let's see what it does. It does create a web app created. Check what happened. So, so to check what happened, you could just say these are like most of the commands you might want to run all the time. Get deployments, and then you can see there's one particular manager that's up and running. His name is web app. Is up to date. It's available. It has an age of 14 seconds. Then you want to run in the command which is um, um, get pods, and then again you can see this in action. There. I believe so. It's running. It's all working live. But yeah. So so what we're gonna do is you can see that the pods are running. There's a test pod that we forgot to delete, and then there's that other random pod that we created. And it was related to some kind of kube mini kube, right? Now what we have is kubectl and describe. Okay. Deployment. And then we describe and then we put the resource type and then we say okay the name of the resource. Okay, and then give us the web app name namespace default. Again, it's in the date particular labels. It's web app annotations replicas one desired It's a rolling update, update strategy, 25% max unavailable. And it has an image of Nginx again. Scaling replica set. Okay, scaled up replica set web app from 0 to whatever it is, but it gave us the information. Now scale the deployment. What you want to do is scale it up. Like suppose we just had like how much? I don't know what it was this, but I think it just created one. Uh, let's see, let's see. Okay, so this is the difference. Single pod, no restart management. So we have this. Um, and then we have manages pods directly. Okay, this creates a deployment that maintains three replicas of a pod using the Nginx container. If a pod crashes, Kubernetes will automatically create a new one. Okay, if you scale up and down by changing the replica's value. Okay, one thing I want to keep okay, does this create one pod in the deployment? Let's see. Let's see. I believe so. Does create a deployment, and by default, it creates one pod inside that deployment. Okay, by default, it would, if we don't like it, what happens behind the scenes is that you run the command Kubernetes creates a deployment named my web app. The deployment creates a replica set manager for pods, and the replica set starts one pod running the Nginx container. And then that's how we checked it out ourselves. And when we scale the deployment and we say scale deployment, and then we say web app, and then we say replica set replicas equal to 3, we managed to add 3 different pods now, all running at the same time, running copies, right? Kubectl scale deployment web app, and then we had that. It's scaled. Now that we do kubectl get pods, it contains, wow, these 3 of them. And I have a feeling that this thing, what I was talking about, is not actually um, okay, so there was a confusion here. What I was thinking is that's not the Minikube um, namespace because if I say kubectl get namespace, I get the default one, right? But you don't want to confuse that with. Don't even think about that Minikube anymore. But just when you're thinking about kubectl get pods, this was your original one that you created with the deployment, right? 4 minutes ago. But when you scaled your deployment, added 2 more running copies of the pod, now these have been created as well. Okay, update the image. Now that we have to update the image, it will, I think, update everywhere. I have a feeling. So if say kubectl set image, and then I say deployment, okay, and then I say the web app, right? So we say set the image of the deployment name web app, and I say I want to have the Nginx image, right? I want that updated version to 1.25. I have a feeling, okay, kubectl, I didn't spell it right. So, okay, I didn't spell deployment right. I'm missing missing keys. Okay, now again, I'm not spelling it right. So it says like set image to another version. Okay, and it should do that. Delete the deployment. So if I say, oh, so if I do cuddle, delete, deployment, and then we have web app, and then should be deleted. So that way, our cuddle get pod, get pods, we just have that one. And then for say kubectl get deployment, no resource found. Okay. Again, it's like S, deployments, pods, right? Okay, and this is the YAML configuration. Again, it's called deployment.yaml, and it has an API apps v1 API version deployment kind. When you just change the kind to anything you want, it will just like you can have a pod, and you just change the kind to a pod, right? If you look at it here, so over here the kind was deployment, right? But over here was kind was pod. So that's why it's just a manager, right? Metadata, web app, then a spec, replicas two, selector, all of that. It just creates two replicas of the template web app container. Okay, Nginx container, running container. So run it, apply FNF, and okay. So let's just do this one last time. Um, so we say vi deployment deployment.yaml. All right, it opens it up in the Vim editor. You go in insert mode, you paste in the thing, you go escape colon WQ exclamation to save that. You apply the deployment, meaning you just create it using kubectl, kubectl, and then you say apply hyphen F, and then you say deployment.yaml, and this should just create the thing. Again, you can just check it out. Say kubectl dot get, and then we say deployments, and then you would see the web app has been there again. Okay, now some of the quizzes. What is the main purpose of a deployment in Kubernetes? Run a one-time task. No, that's just a pod. It's manage and maintain pods reliably. Set environment variables. No, it's the C one. How do you scale a deployment named my app to 5 replicas? Um, so you want to scale it, right? So you would change the kubectl scale deployment, and then you put the my app name of the deployment, and then you say replicas equal to 5, right? I think it's that, yeah. Okay. I have a feeling because we did that before. Yeah, scale. It's the scale command. Okay. And then we have one. So one C two B, one C two B. Okay. Then after that, which command updates the container image for a deployment? Uh, if you want to update the container image, I understand. So you say set image, kubectl set image deployment, my app, and then you want to change the image of Nginx to the 1.25. So it's the C command or C option. What happens when you delete a deployment? So when you delete a deployment, pods remain running. Not exactly, because when I said kubectl, okay, when I say uh, kubectl get pods, it gave 2 pods, right? But if I say so okay, I'm trying to like delete the thing. Um, okay, okay, let's see kubectl delete deployment. The name of the okay, so delete is the command, the name of the resource deployment, and then the name of the deployment. My app. Okay, I think it was not there. Um, okay, my app is not there. It's something else. Apply have an app deployment dot YAML. Web app. Okay, it's called web app. Okay, I deleted it. Now I just have to check get pods. Does this uh, do they exist or not? Kubectl get pods. It shouldn't exist because when you delete the deployment, the pods are also deleted. So what happens when you delete a deployment? Pods, no, only the deployment is deleted, not the pod. It deletes the deployment and the pods it manages exactly. So 4 would be C. Okay, it doesn't do that. D option. Try it and let's see what happens. Uh, so we got all of that. We're gonna move on to the next steps, which is services. Uh, and then we're gonna move on to the next parts. I wish we could have continued, but there's a stop here because the thing is going a little longer. But later on we can definitely, let's see if there's anyone more watching. How much is left? But if we could get all of this done, I think it's step 3, right? How many steps are there? So I think there was like 5 total steps. So I believe we can move on to this part in the next one. All right. All right. Peace out.